Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, we are taking a look at this Macintosh Plus, but this is not just any Macintosh Plus. I think this thing can be considered a field found 64, but in Macintosh form. This Mac was offered to me and given to me by David, who was the previous owner of this machine, and I was told that this thing, well, was stored in conditions unbecoming a computer. I don't know the exact specifics, if this was outside or in a garage that was leaky or what. But the amount of rust that's peeking through all the holes on this machine really show that this thing was exposed to a ton of moisture or was potentially flooded. And I think in this video I want to, take a closer look at this thing and see how bad it really is, and maybe we can get it working. It was handed to me with the idea that this was just a parts machine. Maybe the CRT was still good. But I think I'd like to see if we can get this thing working again. I don't know if things like the keyboard and the mouse are going to work. These are mechanical items that are completely messed up and the disk drive is just filled with rust in here. But who knows? Stranger things have happened. I mean, Field Found 64, that thing still works years and years later after being in, well, far worse condition. Well, I think far worse condition than this Macintosh, although I haven't looked inside, so who knows? So, without further ado, let's get to looking inside this Macintosh. Now, when David came up to give me this machine, he mentioned that he had cleaned the outside. So I think it was in much worse or dirty condition, at least on the exterior. And when you look at this thing, you're like, oh, it's not so bad. A little bit of cleaning will go a long way. But on the back side of the machine, and yeah, this is David's signature here, things don't look so good anymore. Let's see what's in the battery compartment. Okay, we have a little selection of stickers that maybe came off the machine. There's a rusty screw. Oh, there's a couple more rusty screws in here. No battery. Now, even the fastener that's inside the battery compartment is looking bad. And I'm shocked about that because I just wouldn't think that the moisture would have gotten underneath that cover. The power switch, oh, that's frozen. Okay, so that doesn't actually work. This is a Macintosh Plus 1 megabyte. There's some Scotch tape over here for some reason. And looking at the ports, well, yeah, this is that green, crusty, and rusty look that doesn't look good on computers. This fastener here looks pretty bad, and I'm not sure this is really going to come across, but inside the floppy drive, it is so rusty in there. And the whole machine just has this weird staining on it, which I have to imagine comes from rusty, dirty water that this thing was sitting in for a long time. The mouse sort of tells a similar story. You look down the top, it's not so bad, but you look at the side and what's going on here? Like, was this submerged in water for a while? The 9-pin D sub connector, not sure that's going to work anymore. And the keyboard actually looks okay on first appearance, but then you'll notice that the labels are pretty much missing from the keys on the left side, like sun exposure or something. I'm not quite sure how that's even possible. I've never seen anything like that. We have a broken key, which exposes that this is an Alps SKCC keyboard, as all of these are. Typing on it still physically works, but on the back side, all the fasteners are totally corroded, with this one here looking especially bad and rusty. And there's stuff floating around on the inside too, like dirt and stuff. So it pretty much goes without saying, the first thing we should do is not plug this in and try to turn it on. I mean, besides the fact that the power switch is frozen, doesn't work anymore anyways, I think we need to open this thing up and see how bad the carnage is on the inside. So I know this thing has been through a lot. It's not like getting it scratched is, that big of a problem, but I'm just going to put it on top of this microfiber cloth anyways. Who knows? I mean, the case is actually okay condition-wise. I mean, it has the weird staining and stuff on it. It's the internals, I think, are going to be in bad shape. But if Field Found 64 has proven anything, is that electronics are incredibly resilient, and it's quite possible that this thing might actually still work. Not so sure about the analog board with the flyback transformer and stuff like that, but we got to get the reset switch off of here, which was very stuck and it's also very broken. It's missing one of the buttons. I have a feeling David's been inside of this thing because these fasteners that were in the battery compartment are the ones that go in the top handle area, and there was only one fastener holding the back on. So 2 fasteners and this thing, there we go. I saw a little something there. So let's see this together as I slide this apart. There's metal scaffolding and stuff that holds the motherboard and everything in this area. And wow, wow, oh, wow. All right, well, first let's take a look inside the back lid. Okay, it's bad. It's really bad. Typically there's this shiny / dull silverish paint. It's sort of like an FCC filter requirement thing. I don't know, something like that. And while it's still there, it's definitely all kind of corroded away around the ports there. But then this rust, look, you can see where the speaker was, for instance. Wow, it's very oxidized. It's not great. Computer, on the other hand, we're still looking at the side here. Well, hey, the cover's still attached. That's something. It actually has like these foam pads that hold it on. Wow. I've never seen it like this color before. This pad. Oh dear, oh dear. Wow. Has anyone seen one of these this color before? I know I haven't. That's a lot of dirt and yeah, okay. Anyways, I'll put that on the floor. There's the speaker. There's where the flyback is attached. Obviously, this thing hasn't been turned on a long time. Power switch up here. Yep, that is totally stuck. Oh dear, oh dear. All right, let's see what the motherboard looks like here. It's got this kind of a shield thing on here. It's covered in rust dust. The motherboard, this is where I was thinking might actually be okay. Because it doesn't look terrible actually. Oh, it's stuck in there too. Dude, it's supposed to slide up that way. It does not. Well, David's probably going to watch this video and can comment on what caused the computer to be in this condition a little bit more. I don't know if it if it was stored by him or if this was stored by someone else and David acquired it and it was in this condition already. But wow, I'm blown away. I mean, it's very pretty in a way, the color of this iron oxide or whatever that's happening here on the corrosion. One thing you can see, we got a reefa right here. So if this weren't in this condition and you plug this thing in, that reefa is actually installed ahead of the power switch. So if you have something plugged into the IEC mains input, the reefa is energized and therefore you could have the magic smoke come out of your Mac when it's turned off. And you go to like check the power switch and it's off. You have to unplug it. That's the problem with the reefas on these power supplies, this particular one. I think sometimes this one could be a reefa as well. But in the case of this machine, it's only that single reefa. Looking at the CRT, the yoke might be okay. Seems okay, but there's definitely corrosion on the centering ring. Let's see if this connector comes off okay. Yeah, it does. So there might not be nothing wrong with the CRT at all. If you've ever seen revivals of old TVs that have been left outside, they're surprisingly resilient. And I wouldn't be surprised if this thing, as long as it hasn't gone to air, it's probably still okay. And that's even with the corrosion around the implosion band. I think as long as this thing is still intact, it's okay to use the CRT. It's certainly not something you want to do if this is not intact. This needs to be there for safety. I think what I need to just start doing here is take this computer apart into its constituent parts, and that will allow me to, well, see if I can test the various components. I mean, I'm specifically interested in the motherboard. I am noticing, just sort of seeing stuff as I go here. Wow, on the analog board, there is so much rust around the flyback. I'm not really sure where this comes from right here. Unless the flyback itself, like something, I guess it has an iron core, but this is not rusty and the clamp is not rusty. So I don't know what this rust all around the bottom is. Look at these rusty fasteners. Needless to say, this thing hasn't been turned on in a long time, so I don't think there's any kind of danger of high voltage. I've had this machine already for several weeks, just in case someone did actually try to turn it on before I got it. You can't take that fastener out for the CRT without taking the analog board out. And to get the analog board out, there are two fasteners right there, which are kind of small and annoying, and they are corroded, and I'm wondering if I'm gonna have to drill these out. That is unbelievably stuck. And it's a Phillips head, you know, which is not bad if you have the right bit, but yeah, I can't even budge that at all. So I'm definitely gonna have to drill these two fasteners out just so I can free the analog board. And there's also this ground lead. I have to get that off to get the power supply off. That's probably no way that's coming off. And then the motherboard itself, to get that out, there are two ears or tabs, and they're touching the chassis here. And I think those are fused on as well. So that kind of prevents the motherboard from moving. So I need to try to break those free. And I think a little bit of hammering might do it. Oh, that one actually is okay already. Oh, wow, that one moved as well. So those two are not stuck. Let's get the motherboard unplugged. And I am up to date, by the way, on my tetanus shots, so don't have to worry about that. So these connectors came off without too much difficulty. The ribbon cable for the floppy drive and the power cable for the analog board. So let's see, can I get this out? Wow, it does not want to budge. What happens with metal, when it rusts, it actually enlarges a little bit. The oxidation process makes it kind of grow and get scaly. Now the problem is the motherboard is slid into a track, and that track is relatively tight on the motherboard. It's a good tight fit. Well, this is now rusted, and that meant that track has shrunk. So it's gripping onto the motherboard really tightly, which is why it's hard to get out. So that's why I just have to kind of try to bend these away, because if I do that, then I can release the motherboard without having to slide it out. And you can actually bend these out of the way and get the motherboard out that way. In fact, if you have an accelerator on a Mac Plus or one of the other Macintoshes like the 512 or 128, you can no longer slide the motherboard out that way just because it doesn't clear the opening that's on this side with the metal chassis. So you actually have to bend these to pull the motherboard out this way. Although normally you can slide it up a little bit because it's sort of hidden by this lip, this metal lip. But I think with enough bending, wow, there's a lot of like rust scale on my screwdriver there. I should be able to make this work. Yeah, the motherboard's getting chewed up a little bit just because this thing is so stuck on the motherboard. Ah, there we go. I got it. I really have to prise at it. I think I have to do the same thing on this side. Is just really get this away from the motherboard because it's so rusted. Oh, there we go. So I think the motherboard is free now. Well, free being a relative term. Right, so one issue is that these tabs actually lock into the back chassis. I should really be wearing gloves for this. So I have to pry those out of the little holes that they go into. That way I can get the motherboard out. There we go. I think the motherboard's free. There it is. So that's what the Mac Plus chassis looks like. It's very colorful. It's like an art project. You can see the floppy drive right through here, and it still does turn. That's amazing. Oh, the bearing's very crunchy. There's the knob for adjusting the brightness, and it still turns. How cool is that? Now with metal like this, even though it's all rusty and I've sort of bent it up a little bit, it can be bent back. And with a little rust treatment, a little sanding, sandblasting, powder coating, depends how far you want to go, it could be brought back. It could be reused. I had one of these from a Macintosh SE that was totally battery bombed, so I had a bunch of corrosion. I just kind of sanded it and then sprayed it with some rust reformer, and then I put some primer on it, so it's like a gray color. And it's totally fine. It's still in one of my machines to this day. And the rust hasn't really come back or anything now that it's encapsulated. Now to disassemble this the rest of the way, I'm gonna have to get these fasteners off and the ground lug, and then this situation, there are two tabs that hold this on and it's all rusty. This is free the rest of the way. But once that's out, I can take the metal chassis out and I can get the CRT out, the floppy drive and stuff like that, but I'll probably have to drill screws for that as well. And I'm not quite ready to do that type of drilling. I could see some corrosion all along this part of the PCB here. It would have been from the battery leakage, but oh wow, actually, I don't know. Looking pretty corroded. It's going to be hard to see on camera. I think once I get this off, we can take a better look with the top-down bench camera. But yeah, there's corrosion all through here. Some of that would be from the battery that would have leaked and probably gone this way. But I don't know about these traces over here. That could be just from the liquid this thing was submerged in, perhaps. As far as something like the floppy drive, I think there's pretty much no hope for. Maybe I can save this cable. That might be okay. But the drive itself, yeah, it looks absolutely horrendous. And mechanical things like this, in the best of times, barely work. So it's just an 800K drive. Luckily, I have tons of spares of those. Anyhow, let me get this off the bench and clean up a little bit, and then we can take a closer look at this motherboard. Because I think, I mean, it looks bad. It looks bad. Yeah, it looks quite bad. But I think it might work. Maybe. All right, well, here's the motherboard. And I accidentally did a whole segment there, and I hadn't hit record. So that was my fault. What I did is I removed the sims. One of the clips was broken, but the rest are all intact. And you can see the motherboard is not bad at all. Yeah, there's kind of like rust, and this is where the motherboard was really squeezed by the chassis on both sides. But this looks fine. I'm shocked by this. These sockets, these are probably single wipe. I might need to replace those. But the fact that everything else on this board is actually soldered right to it is good. That's a good thing, because this is just dirty and rusty, and, you know, yeah, I mean, a good scrub should really fix this thing. There's no battery on these motherboards. It's actually in the back of the case. So that means you're not going to have the battery leakage. I mean, we definitely have corrosion on some of these legs and stuff of these parts, but easy to change. And these PALs, these have all been dumped, so we can make new ones of those if we really have to. Yeah, it's corroded there, but not terrible. The sim sockets actually look fine as well. I mean, they're just really dirty. And then the sims themselves, they look okay. Now, this thing has been upgraded because they were these two 1 megabyte sims. It's funny to see Intel parts, isn't it? Kingston memory. So it has two of these, and then it had two 256K modules. And I think these would be the original ones that probably were in the machine. I've seen these before. So the machine was a 1 meg machine, but it became a 2.5 megabyte machine. There's that broken clip, which is pretty typical for these. They can be replaced. They're not super easy to find, but you can also just go with one and, you know, put some glue on it or something if you want it to stay in. That's a funny look, isn't it? Maybe there was a cobweb or whatnot that got rust encrustified. Yeah, see, it kind of does move around a little bit. These chips, yeah, they're not looking so hot over here. Like, look at this corrosion there on that leg of this PAL, the lag chip. But again, we can make new ones of these. And then, yeah, this is where the motherboard was really squeezed in there. And see, I pried it away. You can see the scrape marks there. That was because that rust jacking just really held the motherboard very, very tightly. Things are looking okay, though. I'm really, really surprised. Here's evidence of our RAM upgrade. This resistor would have been in place originally. That would have made this thing a 1 meg machine, and you cut this, and then you can go to 2.5 meg. And I think if you have only two sims installed, like two 1 megabyte sims, you would have a resistor in this position. Our buttons look a little corroded, but they are both clicky, so that's nice. And looking at our ports, well, yeah, you can see like it's green and crusty inside there, and they're probably not going to work super well. And the problem is these are riveted on, so you do have to drill this out if you're going to swap these out. I've done that before. I think I had a video where I had a really corroded Mac 512 motherboard. I had to swap some of these out, and I stole them off other parts motherboards, because luckily I have some parts motherboards. Floppy drive controller is the only rare one. Obviously 9-pin, very common. 25-pin, super common. This is the one that's hard to buy these days, so you have to steal this off another motherboard typically. And then the DIN jacks, also I can steal these off another motherboard, no problem. Now let's look at the bottom side of the motherboard. Let's check out that corrosion situation. I mean, it's fine. I don't see any corroded traces whatsoever. Obviously the biggest concern is in this area, and even under this mess here, it looks okay. There's really nothing wrong at all. This motherboard's in far better condition than the Field Mount 64, which had a lot of corrosion under the solder mask. Yeah, this thing's looking good. I'm pretty confident, unless this motherboard is broken for some other reason. That scratch there was from me with the screwdriver and right here prying into it. I'm pretty confident that unless this was already broken, this motherboard probably is going to just work once I clean it up and maybe replace some of these ports. Yeah, looking great. So that is the Mac Plus motherboard that needs a good wash. Shall we take a look at the mouse while we're here? Because It's sitting on the bench, and let's get that fastener out and take a look on the inside. This has a nice case, at least. Well, it is stained, but I think I can maybe clean it up with magic eraser. So it's always good to have some extra parts like this, because you never know if I'm gonna, encounter a mouse that needs some TLC. And I don't really think there's any kind of hope of of saving this. No, that's not good. That's not good at all. Boy, it's like rust all over my fingers here. Okay, and inside our mouse, things don't look, they don't look so hot. This thing was probably submerged. It's gotta have been submerged. So yeah, we have some serious corrosion activity in here. This obviously, yeah, wow. Like this spring here, that spring has, or whatever this is, that has left the chat. That is no longer good. The rollers are okay though. They're obviously made with like stainless steel or something. Yeah, these still turn, and that wheel is okay. The switch, nice and clicky. Yes, and it looks like it's Omron, of course, good quality. Yeah, it's still in good shape. There's our wheel, or our ball, I mean. It's like a planetoid. Yeah, definitely this was exposed to, well, that's just a whole lot of dirt and a whole lot of corrosion. This mouse might actually still work, if you can believe it. I see it's made by Alps. I don't think I knew that they made Apple's mice for them. But yeah, this thing might possibly work. Is that a botch? Oh no, that's like some kind of a shield. Well, that was like added after the fact, wasn't it? Goes all the way around. How interesting. I never noticed that. I haven't opened a whole ton of these, but look at that little bodge wire there attached to that little piece of tape here. Interesting. There are parts to be had here. There are definitely parts to be had. So if, something is broken and I have a broken mouse, I have case parts at least. Yeah, they're stained. And I don't know about this board working and, this connector and stuff, but hey, it's Apple parts, right? Okay, well, the bench is a mess. I'm going to go upstairs and I'm going to give this motherboard a big scrub, and we'll come back and see how it looks. I think it's going to look so much better. Here it is. This is the motherboard all cleaned up. Would you look at how much better it looks? Dare I say, this is just gonna work. I haven't touched anything when it comes to the two ROM sockets. So those are the two areas I might see issues. And of course, we have our potentially bad ports. The real first test is just grabbing a working Macintosh and connecting this up and see if we get any signs of life out of it. First, I'll start with that, and then we'll add the memory back into this motherboard, see if it can work. So here we have a Platinum Macintosh Plus, which I think is what the rusted Mac actually was when it first started out. This one, though, of course, doesn't have any kind of corrosion or any issues like that. I have it sitting on a mouse pad, so it spins around easily. This thing totally works, though. I've been doing some other work on this machine without any issues. So let's get this motherboard first connected up, and an easy way to do that on these machines, so I don't have to slide this in, because obviously this doesn't have any memory on it, so can't possibly work. It's just connected up like that. And I have power connected up to the computer, although the power supply is off, or the power input is off. We'll just turn this so you can see the screen. And when I turn this on with no RAM, what we should see is, well, actually, we won't really see anything, but let's just see if anything catastrophic happens with the motherboard sitting off to the side there, just so you can see it there when I apply power. All right, 3, 2, 1. Oh, power switch is off. All right, here we go, 3, 2, 1. Okay, we got a tick out of it, and we shouldn't see anything on the screen necessarily. I can tell the high voltage is running though, which is correct, because the PALs and stuff on the board should generate the horizontal and vertical sync, which should make the monitor work. Yep, but we have nothing on the screen, which is normal, but there was high voltage. Sounds like there was at least. So I think what I'm going to do is I'm going to install some known good memory. And the way the configuration resistors are set up here, this is either set for 4 megabytes or 2.5 megabytes. That's the current RAM configuration on here. So I'm going to put these 1 meg sims in there. This one has the broken clip, but it should still hold it in with no issue. RAM is installed. Let's turn this on. We do not have a working system, but let's see if we have any kind of patterns on screen. Oh, we do. That's a good sign. The fact that we have a good screen displayed tells us a lot of things. The horizontal vertical sync is working. That means the clock is working. It is currently running. The PALs are currently refreshing the memory and they're accessing the RAM, which is generating this pattern. This pattern will be different depending on what kind of DRAM you have installed, but that's what you get when it's not initialized. The CPU is probably not executing code right now, and that's probably because the ROM sockets are bad or dirty or whatever, and that's not allowing it to actually read the ROM code out of the ROMs. So I think the next thing to do is just deoxit those sockets for the 2 ROMs, these ones right here, and let's see if we can make it work. They're warm, so they're getting power. I can feel the chips on the board are kind of warm, but yeah, there's definitely signs of life on this Mac Plus right now. That's cool. So I think everyone knows the drill. I'm gonna grab my little chip lifter. Let's get these 2 ROM chips out of there. In fact, what I need to do first is I just need to mark them. So this is high, that is low. Just makes it easier when I take them out and put them back in that I don't misplace them. So when I cleaned this motherboard and washed it and whatever, I didn't take these chips out, I just left them in there. So it's quite possible we just have dirty contacts, and I can tell that these are not good looking sockets either. So that's pretty typical stuff. So in goes deoxit, just the regular stuff. I have low blood sugar. That's what my insulin pump was beeping about just now. I can see dirtiness inside these holes for these sockets. So that hopefully will do the trick, but let's see what happens. Deoxit is pretty amazing. It honestly is. So I might need to just sort of take these out and push them in a few times, just with the deoxit in there, of course. Oh yeah, that comes out a lot better. It was kind of crunchy feeling when I took it out the first time. Okay, motherboard is reconnected. Let's see what happens now. Aha, look at that. That's all it took. That is all it took. So it's doing the RAM check right now. I have the brightness turned down a little bit. And let's see what happens. I knew it would work. I just knew it would work. Those motherboards, they're very reliable. The one thing that you might have to do sometimes is reflow the solder joints on the bottom of the connector. And that's usually the case on the analog board itself and not on the motherboard. And this motherboard or this computer has already had its bad joints reflowed. And it's not flashing right now, but that's pretty typical if the floppy drive's not plugged in. It's kind of sitting there and it's trying to access the floppy drive that's not physically plugged in. Why don't I slide the motherboard in, we'll get the Blue SCSI hooked up and we'll get this thing actually booting into Mac OS or System 6. And the one thing I want to do before we do that is let's flood these connectors because they are bad looking with deoxit. I should have probably used the stronger version of deoxit. That's deoxit D50 or something like that. This is D5, this little squeezy bottle. That's why it's kind of like this slightly off pink color. If it's not effective and doesn't work properly, then I'll move up to the stronger stuff. For Macintosh Pluses, if you're going to be using something like a Blue SCSI that is this external type, it doesn't get self-powered. You have to make a mod to the motherboard, so I do have a USB cable to power this up. Oh, it's kind of crunchy going on there because of the rust that's on the 25-pin connector. Okay, here we go. We ready to see if this thing boots into the operating system? 3, 2, 1. Sounds normal. The floppy drive is connected as well, even though I think this floppy drive might have a broken gear. I think it probably works, but yeah, the eject gear doesn't work on it. I had a little stash of 3D printed gears for these and I've run out and I just haven't reordered more. And I think they need to be resin printed since regular FDM 3D printers, it's just not fine enough, the resolution. Ah, okay. We are not booting. That is interesting. And the Blue SCSI is powered up. I'm assuming we're getting bad contact inside that 25-pin connector. I should probably just double check real quick that the drive image that's on the Blue SCSI is one that can boot the Mac Plus. Okay, yeah, obviously this is a different motherboard. I just plugged in the Blue SCSI directly into it. So the problem is definitely the motherboard. So either we have a bad SCSI controller or we have just bad contact inside the 25-pin connector, which is the most likely scenario of those two. Now, I think I'm being silly just trying to make this work because obviously I could just replace it. All of these are very easy to get except for the 19-pin for the floppy drive, but the 9-pin and the 25-pin, I mean, I have those in stock. But let's try out Deoxit D100L. Stuff is super concentrated. So I will just drip this in carefully to all these ports, and then I'll have to grab something to kind of plug in and unplug from the pins just to make sure it gets in there. I can sand off the corrosion that's on the outside of the shroud part, and that's not a big deal. But if I can make this just work, then hey, that's great, right? And I guess while I'm at it, let me plug in a mouse, since I've flooded this with Deoxit as well. And this is obviously the non-rusty mouse. The other one, maybe I can make it work, but I probably just have to leave the connector that was all corroded in some evaporust for a week or something like that, and then that might work again as well. Okay, here we go. Let's see. Will this work now? Oh, maybe I should plug the motherboard into the power supply. It would work better. These analog boards, they don't appreciate having no load. You'll hear them sort of tripping out and chirping, and that is exactly what was just happening right now, because I didn't plug the motherboard in. There we go. Now it's all plugged in. Here we go. 3, 2, 1. Oh, we have no sound. So that's weird. I thought the machine would have been crashed, but it's obviously running because this is the test pattern. But why was there no beep? That was weird. Could be we have bad solder joints on the bottom of the motherboard. As I mentioned, that can happen there sometimes as well. Or the computer's just frozen at the RAM check here. But I think I have 4 megs in here, so it takes a little bit of time. Oh yeah. Oh yeah, look, it's booting. So, and it's slow, I think, because I powered off the other Mac without shutting it down. I didn't have the mouse plugged in, but let's see if the mouse works. It freaking works too. Yeah, this thing is a survivor. I mean, I know this is only the motherboard, and the rest of the computer is still untouched. Once this comes up, we'll look at how much RAM we have. I think, yeah, 4 megabytes is what this should be, and the lack of sound, I'm going to reflow those joints on the bottom of the motherboard. That might do the trick for our sound. Oh, the mouse button doesn't work. Okay, so we're not totally out of the water here. But even though it was in such bad shape, just some soap and water and scrubbing is all I did upstairs, and it came out pretty clean. And I mean, obviously we're just having connection problems now. I'm going to jiggle the mouse connector. Yep, there we go. So if I just kind of turn it a certain way, there we go. And we have 4 megs. Cool. So yeah, all the 4 SIM slots are working. I mean, this thing is just a survivor. Absolute survivor. How awesome is that? All right, shutting this thing off. Let's see what's going on with the sound, which we heard work a second ago. Just making sure I have the connector on there all the way. It is. Let's double check we power up. We don't hear a beep now. Okay, we're getting a beep. So I wonder what's happening there. I wonder if those connectors, the pins on the motherboard on the top side are oxidized a little bit, or if we are dealing with a little bit of a bad solder joint situation. So I'm just gonna take a look, because I've definitely run into that. You just flip the Mac on its side and you just take a look at the pins on the bottom. Let me inspect. Yeah, they look pretty crusty, and I think they're a little bit cracked on the bottom as well. I always have a hard time showing that on camera. So all I need to do is I'll just reflow these on the bottom. That usually is all I need to do to correct this issue. If you have a Mac 128, 512 or plus, you really need to reflow the joints that are under this plastic cover. And this one has little rivets to hold it on because it's a later Mac Plus, but the earlier ones is just stuck on with some double-sided foam. You just peel that back and then you just reflow those joints. And a lot of times that will fix, especially like if you have video that cuts in and out, that is almost always caused by a bad solder joint right there. And if you tap the machine and it comes and goes, that is going to be the fix. Although there have been times when I reflow this stuff and it's still doing it, and yeah, then it's what's on this connector on the bottom here. All right, reflowed. Let's see if this thing comes to life still. The beep sounded good. Where's our mouse? Stuck back here. Now while this boots, I have to admit that the motherboard was going to be the easy part. I just sort of knew this was going to work. And maybe I'd have to change a connector or two, and maybe that's still the case if the mouse button doesn't work. The problem was going to be this board. The analog board, I did take it out of the case, and I had to drill out all those screws, but this is looking not so hot. Obviously, the speaker's in bad shape. I can replace that. That's no problem. But Yeah, it's not looking good in some other areas as well. So I'm not so sure about this working, but hey, we got to try, right? All right, okay, computer's booted up, mouse is still working. Let's just double check our sound, make sure that's still looking good. Yeah, we still have working sound. Cool. Okay, this is the power supply board, up close and personal. We still have a reefa on there. I'll have to remove that before even trying to power it up. Actually, looks like the reefa has already given up the ghost to some extent. Looks a little broken there. So this board's in interesting condition. Some parts of it look fine. Like these components here, no issues whatsoever. But then look at the fuse holder. I think it's actually broken. Yeah, that doesn't seem normal. Those shouldn't be quite so wobbly as that. So I'll obviously have to figure out somehow to bypass the fuse here, or clip it into place at least. Of course, the thing that looks the worst is the speaker. And yeah, I'm not sure that this is this ever gonna work? I mean, maybe. All right, so it's still connected up to the board, so it's not gonna be the most accurate reading in the world. Let's see if it's open or not. 58 ohms. It's not like I can read what that is, but I assume that would be an 8 ohm speaker. So that doesn't bode well. Now looking up close again, this is where it was up against the chassis. I had to drill these fasteners out. And then this bottom edge sort of has a metal clip that's around there. It's very difficult to get out because the rust jacking, which basically was the metal rust, it enlarges and it squeezed the board. So it really held in tight, even though there was no fasteners down here, just sort of these clasps, but that was really hard to get out. The potentiometer here does turn. It looks a little worse for wear, but I'm not sure this is, yeah, look at that rust there. Not sure that's really gonna work. This was another area where there were fasteners and it was very difficult to get off. I drilled it off, but no damage to the board has occurred to it. Power switch, we know that's already in a frozen state. So I'll just have to jump over that to turn this thing on, or to attempt to turn it on. And yes, I am gonna try to turn it on. Top side of the board where the flyback is, well, this rust you see on the flyback is all from the bottom here. And you can just see, yeah, I don't know. I don't know if that's gonna work or not. And then this inductor here obviously has an iron core and that's sort of leaked as well. These two transistors here, this is obviously for deflection, or actually this is a diode, that's a transistor. They look worse for wear, and then oddly around the capacitor there, it looks kind of gross as well. And all of this here, my assumption is this was all just the rust kind of pouring off of the bottom of the flyback and just staining this section of the board. So believe it or not, I'm kind of afraid to try this, but at the same time, I kind of want to try it. I think what I'm going to do though is I'm going to disconnect the top part of the board, which is the CRT driver section, from the switch mode power supply, which is this section down here. My recollection from a previous video is that there is one diode, or maybe it's a resistor, that brings the 12 volts from the switch mode power supply section of this board up to the CRT driver. And all you have to do is remove that. That will disconnect power from the entire CRT driver section. I have these recreated schematics for the early Macintoshes, and they're all the same basically. Looks like it's L1. This is what connects the power supply to the sweep circuit. And this is the inductor right here. That's L1. It's marked on the board. And we flip this over. Yep, okay. So it looks like what's happening is this is the 12 volts that comes down from the main power supply, this thick trace, and that's the connection to the rest of the CRT board. So simply removing this component, if I can, it's not too corroded there, that will de-energize the entire CRT section, which is good for just testing this thing. All right, there's inductor L1 removed. So that means high voltage is safe. I mean, meaning this part. It's not gonna generate any high voltage. Now, the Macintosh driver circuit, this is not a free running circuit. It will not generate high voltage unless the motherboard is supplying horizontal sync. If you power up the power supply with a load without a motherboard sending horizontal sync into this connector, then the CRT circuit can't really generate high voltage either. But just removing this is just a good way to be safe about this. Now, this is a fool's errand, right? Don't do this at home because there are high voltages all over this board and it can be dangerous. To power this up in a safe way, I'm going to use an isolation transformer just in case something goes wrong, and I should wire up a light bulb. I think I have one I can wire in line with this. That way, if this thing goes dead short, then basically the light bulb will turn on full brightness and I'll know that, well, the power supply section is shorted, and that would just blow the fuse instantly anyways. One other thing you can do before you power up something like this that's completely unknown is use your diode check mode on your multimeter to go through all the semiconductors, at least on the power supply section, and make sure that none of those are shorted. Obviously, for a switchable power supply, that means switching transistor and the diodes that are around the power supply. Those are the most important things. If any of those are shorted, well, that could just instantly blow the fuse on this thing. I think what I'm going to do before I try to power this on those, I'm going to take it outside. I'm going to spray this contact cleaner all over it. And I'm just going to try to get some of this iron oxide dust off of it. It is covering the board, and I don't know if it's conductive or not, but it was made from metal originally, so maybe it is. So let's just get it off this board as much as I can, and then, yeah, then we'll give this thing a try. So I'm going to get set up, and I'll be right back. Okay, so the power supply has been rinsed off outside. Doesn't really look any different, but I gotta say, it doesn't really shed a lot of this rust material that's on it. I did get the power switch freed up by just spraying a whole bunch of cleaner inside of it. It's still crunchy feeling, but at least it moves. That's working. I didn't really adjust any of the pots that are on here, so we might need to fiddle with those. I do have the light bulb set up here. So this is a 40-watt light bulb that's in here now. And this, you can't just see it off the edge. This is the isolation transformer. Basically, it goes from the mains to the isolation transformer, and then the light bulb is set up in series with the load. Now, this is the power cable that comes from the isolation transformer. It goes into, well, goes through the light bulb, 40 watts, and then it goes into this gray power cord. So if we turn the system on right now and I measure this without any load, we'll see 125 volts, which is my mains at home. But as soon as you put a load on it, the light bulb actually will act as a big resistor. The higher the wattage bulb, the less voltage drop will have across that resistor. But I think 40 watts is probably a good place to start. I have a box full of different light bulbs, including like this one that's got multiple wattages on it, although it's a three-way, and this socket is not a three-way socket. I don't have the load obviously plugged into this, the DC load, so if this does work, it will just turn on and then start, going into a fail-safe mode. Now, I'd like to hook up the multimeter to this connector so I can measure the voltage coming out of here. There's a missing pin, and the pin that's on its own, that is the video signal, that is pin 1. The opposite end over here, pin 9, that is the ground signal, then -12, ground, and +5. So with the clip lead, I'm just going to clip on, and we're going to measure that 5-volt rail when I power this thing up. Currently, the entire power to the transformer is off, so I can safely connect up this power cord to here. Of course, the fuse is missing as well. Where is that? Right there. I did take that reefa out, so that's fine. It's not going to let the smoke out. Thank you. And I just need to bypass this fuse. I'm going to use this thick clip lead right here, just so we can not have to worry about that, since obviously the fuse holder would need to be replaced if I was going to actually use this thing. This is switched on. This is connected to the 5-volt rail. 40-watt light bulb is in series. There's no load, so this thing won't really regulate, but I'm going to expect to see some kind of voltage coming out of this, or it's going to, well, turn on the light bulb full brightness. Well, I don't know. Let's just see what happens. Okay, here we go. 3, 2, 1, and I'm stepping back. All right, it's running. Why was that showing a negative voltage though? That's weird. Okay, I see the problem. I was looking at the incorrect pin out. So video is up here, pin 1, but pin 9 is actually ground, and I was thinking that this was ground and that was 5 volts while I was on the battery connection. So really, it needs to be pin 9 and pin 6. So pin 9 for ground, that's going to the ground lead on the multimeter. And then pin 6, where this orange lead is now, that is correct for 5 volts. So let's turn this on and just see if we see any kind of positive voltage happening here. Okay, I was kind of running, but it was unhappy, but it was running, but it was a positive voltage. All right, I'm going to get the electronic load. I'm going to put some load on this thing because I think the way it is now probably doesn't make the power supply happy. Not to mention, it's probably only getting like, 60 volts AC going into it as well, but at least no smoke came out of it. Okay, so again, this is set for 10 watts of 5 volts, the DC load. I'm wondering if 40 watts is not quite enough. Switch this out with higher wattage bulb. Here's a 60 watt incandescent. Let's try this one. Here we go. It's making a very high pitched weird noise. And it's not even turning on the light bulb at all. So that's kind of saying that it's not really drawing too much current right now, but yet it's not starting. Let's try to adjust this pot and see if we can get this to regulate a little bit better, because I think it's just unhappy. Like I said, this is all a bit of a fool's errand. It's going to get some deoxit first because that's pretty crunchy. And we'll turn this pot and make sure it even works. Oh yeah, it works. Crunchy, crunchy, crunchy. A little more of this deoxit on here. Okay. So I just set it for the middle. Let's turn it on, and I'm going to turn this and see if the tone changes. I'm not even sure that's the right pot that I'm turning. Oh yeah, it was not the right pot. It's actually this one right here. I just couldn't see it behind this capacitor. It's that one. Power's off right now. Let's hit it with deoxit here again. It's very crusty looking. Okay, it turns smoothly. So the weird chirping the power supply is making, it should change as I turn this. So let's give it a try. It's not really changing. Now, if we take a look at the schematics, the voltage regulation circuit, this stuff right here, goes through an optocoupler. It is looking at this line right here, which, oh, actually it's regulating on the 12-volt rail. Ah, not 5 volts. So all these windings are kind of interrelated when you have a switch mode power supply. Basically, we have -12, +12, and +5. You notice these all come off of different rails, but see how they're all in the same winding? That means they all sort of interrelate with each other. But generally, the regulation is going to be happening. It's going to be looking at the 12-volt rail. So maybe this voltage rail is going too high because there's just no load on it whatsoever, especially because the 12-volt or the CRT section is disconnected. So let's hook up the clip lead to the 12-volt rail, which we go here, +12, which is this one. And I'm going to apply some load to that rail. I'm going to set the load to draw 5 watts from the 12-volt rail. Actually, 10 watts is probably fine. So let's put it back up to 10 watts. 10 watts on the 12-volt rail. So let's see now what happens when I turn this on. Oh, it makes a high-pitched chirping noise, doesn't it? Let's turn this pot. That's doing nothing. How about this other pot? It's generating 1 volt or thereabouts. That's an unhappy camper right there. It's funny that this trim pot down here doesn't seem to change the frequency that it's chirping at. I would expect if it worked that it would do that. So I turn it on again. It like literally does nothing. The 12-volt rail just has about 0.1 volt on it. I know you can't see that, but that's what the load is showing on the screen. And yet, I don't know, maybe this is too much of a load for it. Let's turn this down to 5 watts. It does nothing different. Oh, it kind of started there for a second. Yeah. Oh, got some smoke coming out of something there. I don't know what it was either. I wasn't looking. Did anyone see what it was? Oh boy. All right, well, I let the smoke out of this thing, and I was just adjusting the load there, and it kind of started for a second and then got very unhappy. So where did that smoke come from? It was somewhere in this area right here. Can't quite tell what it was though. Was it that resistor? No. Well, I think that was just a little bit of a fool's errand trying to get this working. I've worked with enough of these to know that this board was very unhappy there, and that high frequency chirping, they do normally chirp if you don't have any load on them at all, but I did have the load on it and it still wouldn't start properly. And when it did, well, then we saw that smoke come out. I don't even know what it came out of. I still can't tell. Nothing looks burned on the board there. And I actually reviewed the footage, and it looks like the smoke just kind of comes out from underneath this connector. So yeah, I'm not sure what was going on there. I think this is going to be a parts donor board at best. And the parts on here are really heavily corroded, so this is more of a showpiece more than anything else. But there are still good components inside the case. So let me grab the case and let's take a look at what's left in there, which is the CRT and the yoke. And that's really it, actually. Let's see if that stuff works. All right, here is the chassis. And, well, yeah, the CRT, it's free. All the fasteners are out. Let's lift this out. I don't want to scratch this. I need to put something down so I can not scratch the screen. Don't want to put, even though it's glass, you don't want to put it down on top of something like sand. Could potentially damage it. I've also removed the fasteners from this. I have not, because it doesn't come out. Where is there another one? All of these are out, I thought. Is this rust jacking? Oh, yes, it is. That's exactly what's going on. Oh, dear. Look at this. Oh, boy. Well, the case is fine. Whoa, whoa, whoa. Don't fall over. Don't fall over. Look at this. Just moving it makes a mess. That's why I put this paper towel down. There's nothing wrong with the front case. Obviously, with a little... Oh, this is interesting, I think. I was thinking that we could kind of see where the water line was, but I don't know if that's exactly what that is. Maybe? See that? So was this lying on its side, like in a pool of water, and that's why the power supply board was so screwed up? I guess, yeah, that would be it, right? This is what we saw as well. So this thing must have been sitting on its side, and it just happened to be the power supply side, and that is why it is so bad. You can see it right there as well. Oh, you poor Macintosh. This chassis is actually still usable, theoretically. It would just need, I mean, sandblasting, I guess. If anyone is willing to sandblast this or vapor blast it here in the local area, let me know. Because with a little paint, we could probably make this look plenty usable again. I think it would need a lot of sanding on these rails, though, where the motherboard goes in, just to get the scale and the rust off. But I think a wire wheel would probably take care of that without any issue. But yeah, there it is. All right, Sony drive. I really don't recall this piece of plastic being here on the top of the drive, but I guess that's because look at the floppy drive, everyone. Are any parts of this good? I don't think so. I mean, it still moves. Doesn't latch properly because all of this stuff is just completely frozen. If you flip it over, we can see the day code, 1986, 6th week, and it does still spin the motor. This is the earlier of the 800K disk drives. So I think, see all these MILF components later, just the board got simplified. I've seen plenty of these, and luckily I have spares of these disk drives. So this thing does not need to survive. Those heads don't look too bad, but I wouldn't really even bother to try to save this thing. I am gonna pull this off. That's interesting. This is such an old unit that this little mechanism, I think that's a micro switch here. So we have a little cam thing, and as this turns, that switch obviously goes over into this direction here, and that lets this know it's completed a full cycle for the ejection. Let's get this out. There is so much rust even on the tip of the screwdriver. It's not really magnetic, but it's kind of magnetic. Yeah, this design is a bit different for this eject motor. Do I have another one just sitting around? I usually have one off to the side, which I can't find right now. Typically, this plate is held on with clips. So this is a slightly different design that actually is a bit better, probably. I'm assuming this still has the gear inside that self-destructs. They pretty much all do. There's our gear. This is the one that self-destructs. I'm sure it is ready to go. You just lift this one off like that, and then you can take this gear out. Oh, it's extremely stuck in there, and you can see the corrosion, a little green there, and on this here, this is the motor, which it does spin. It sounds terrible. You won't be able to hear it in the video, but as it turns, it's like... So I think that motor is bad as well. But now if we turn this, you can see the cam action. So this mechanism is inside this gear set on later ones, if I recall. Yeah, because it doesn't have this whole setup on the top. This is interesting. This is a later thing. Anyhow, you can buy this gear online, 3D printed. They're pretty inexpensive, resin printed, and that will fix your disk drive. And then once you get the new gear, you stick it on there, and then you slide this one on top like that, and that brings this thing all back into normal operation. I have just worked on a lot of these drives, and here is what they normally look like. So it has a little circuit board, and that little switch circuit is actually integral to the unit. So you have to like pop that off, and then you will be able to clean that contact. Because if it gets dirty, the thing will just run continually, even if you change that gear. I'm quite certain that this is 100% compatible, so you could just swap this over, but just looks a little bit different. And the part number on the one on my left hand, R2DG-38, and this one is a -31. I am most definitely going to hold on to this, even though it's super corroded. You never know, I'll just need a spare part, like maybe I need that cam, switch over to another one of these -31s, or this little piece, or, whatever, just like stuff like that. This plate, it's not great, but I guess that wouldn't that wouldn't normally be missing. So for me, even though this thing is in pretty terrible shape, if I can save another floppy drive at some point in the future by having this, then that's a win. That's an absolute win. Now, as for the floppy drive itself, we can compare it to this one, which is another similar one with the MILF construction. Clearly, I'm not quite sure there's anything necessarily worth saving on this one, just because of how bad the condition is. All right, so that brings us to this, the CRT. Again, I don't want to scratch it by dragging it across the table. Yeah, that's a little concerning. The CRT itself is going to be fine, but this band you see attached around and strapped right here, this is the implosion band. Now, if you haven't thought about what this does, if you look at the front of the screen, it's curved outwards, right? So if it were going to go inward and implode, well, the glass would have to get bigger. It would like flatten, right? As it flattens, it gets a little larger. Well, the steel band is what kind of compresses the CRT just to help prevent that from ever happening, from this enlarging. So if this was removed, and this does contain the mounting ears, it's actually potentially dangerous. So you don't want to ever have that be the case. The only thing I'm concerned about is the deflection yoke. Now, we obviously have lots of rust here on that fastener, on these rings. This is the centering rings, these two. Yeah, there's one there and one here. There's two of them. All of this is super rusty, but it probably will work. Oh, yeah, this isn't, I mean, none of it's good. None of it's good. Like all of this. But if you never need to take it apart, you would never take that apart. But if you never need to take this off, which is that fastener there, then it's probably fine. And I mean, if this is still good, oh, you know what? We can actually test this. Let's test it before I even bother to break out another power supply to plug this in and stuff. So to test this, you could just use a regular multimeter. In fact, let's just do that real quick so you can kind of see the values that it should be, if it's working, that is. So just put your thing in resistance mode, like so, and then figure out where the connection is between all these wires. Now, usually, I don't remember the colors, to be honest. I can never remember, but let's just see. It should not be open. That's open. Or we just have really, really bad contact in there. That could be the case as well. So I have a little thing here full of some nails, and these are perfect for sticking in there, like these bigger ones. All right, so let's see what we got. Okay, we're good. 1.45 ohms, that's fine. So it's the green and yellow wires, and let's switch over to the other two. These should both be pretty low impedance on the multimeter. 10 ohms. I think we're good. So it's not open. Doesn't mean it doesn't have shorted turns or something like that. Still could have that. Now we're going to grab this, which is my LCR meter. Now this is something that most people won't necessarily have. So this measures, obviously, it's good for capacitors, but it also can do inductance. So the L mode is the inductance mode. Let's clip this onto here. All right, so we got 14.5 mH, which I think is millihenries. The U would be microhenries. I'm just going to write this down. We can compare it against the other Macintosh that I will be bringing out to test this with. So 14.52. And I think the other one is going to be lower inductance, if I recall. But let's see. Yeah, 78.4. And this is a UH, so millihenries. Okay, so what I'm going to do is I'm going to spend just a moment here just to kind of clean this off a little bit because it's kind of dirty to touch, and I'm going to grab another one. We'll test against that one. Also give me a good indication of how much use this CRT had before the Mac was abandoned into a puddle of water. The more black soot, the more use it had. So if this was coming off perfectly clean, then I would know that this was like a brand new CRT before it was abandoned. Right, so the final step in this video is going to be testing out the CRT in this working non-rusty chassis with a working power supply. And I'll be testing the power or the motherboard that was in the rusty machine, which we already know works, so we tested it, actually tested it in this machine. But I want to see if this CRT fully works and how good is it. So here is our rust bucket CRT, cleaned up a little bit, but all the rust is still there, but that's fine. Now, one thing I'm a little concerned about is the connection from the deflection yoke on the rusty CRT. We know that it's looking pretty bad in there. So I'm going to put a little deoxit in there. The horizontal deflection is actually relatively high energy, and when you have a bad connection in there, it can melt the connector, especially on the board itself. Well, usually if there's a bad solder joint on the board itself, then this this ends up getting melted. So I'm just going to drop a little bit of this D100 in here just to kind of help the situation. High voltage anode connection is good. Ground strap is on. Oh, I just do need to tighten this screw here. I had it loose so I could get the CRT fasteners in. There's a little bit of play, so you can rotate the screen a little bit. If you have it where it's rotated a little bit, you can loosen all four and turn it a little bit. All right, that's all connected. Let's get the rest of this assembled. Okay, here's the original rusty motherboard ready for installation. And let's see, will this CRT work? I'm sure it will. 3, 2, 1. There's a little bit of the tape hanging down there from the front. Look at that. Perfect deflection. And you know what? CRT looks good as well. Let's rotate this so you can see it a little bit better. Yeah, it looks centered, which is a good thing because those centering rings, they're stuck. That's hilarious. This CRT is good. I cleaned it. I think it's got a little scratch right there. Actually, you know what? It does have a little bit of burn in. So I stand corrected. I could see a little bit of a menu bar at the top. So I guess this was a well-used Mac. I mean, there was some soot on the CRT as I was cleaning it. But it's plenty bright though. It's not like it's totally worn out, but that's typical. These are pretty long-lived CRTs, these Clinton CRTs. But yeah, I can see where there was a menu bar at the top. So it's slightly burned. Ah, you know what I forgot to do? I forgot to measure the inductance of the yoke on the other CRT. I'll grab that, and while I do, I'm going to plug in the blue SCSI so we can get this thing booted up. Part of me says there's really no point to test it because this one obviously is working perfectly, but we might as well. I have the tester out, right? Okay, here are the measurements on the good CRT. 14.58 versus 14.52, perfect. And 77.2 versus 78.4, also perfect. But we know it's perfect because it looks perfect. I wonder how many years it's been since this thing has displayed any kind of Macintosh operating system. Yeah, I'd be happy with this if this was like back in the day and this is what I was using. It looks fine. All right, why don't we test out some peripherals? I have the keyboard sitting there, and then how about this mouse? I'm not sure this is even gonna work. I'd have to soak this in Evaporust. That connector, there's no way there's any contact being made there. Okay, so I'm not gonna test the mouse, but the keyboard we can test. I guess what I should probably do first is I'm gonna plug in a known good keyboard, just so we can see that it actually works. Does this known good keyboard work? Yeah, works fine. How about this one? I haven't even opened this up. It's got loose parts inside. The connector here looks perfect, so no issues there. Okay, that would be a negative. It does not work. Do any keys work? I mean, it doesn't feel so bad. No, no keys work. Let's just double check that it's not a problem here with this connection. Jiggle that around. Oh, it started working. What? Okay, so certain keys work. T sort of works. Y, U, amazing. Alps SKC switches for the win. How freaking cool. Even has a nice ping sound to it. Nice. All right, well, there we have it, everyone. This corroded Left 4 Dead field found Mac mostly works. Digital, no problem whatsoever. Keyboard kind of works, and the CRT even works. I just didn't get the power supply working. I'm wondering now, I was sort of thinking about this while I was editing the last chunk of the video, that is, that maybe I should not have had this on the light bulb. Switch mode power supplies don't always behave quite right when they're on a light bulb, because when the light bulb is not lit, this thing will see 125 volts or thereabouts, you know, maybe a little bit lower. But once it lights up, this might have been seeing like 80 volts, and maybe it was really struggling to run at that voltage, but it was making all those chirping noises when the light bulb wasn't even lit. So I would think it still had pretty good line voltage and it was really struggling to get going. I also don't really get where the smoke came out, because it really came out around the connector here, but it's really corroded and there's a lot of junk around it. And in fact, there's like a jumper link right here that's all crusty. So maybe it was that had the problem. I really didn't want to just plug this into what is a known good motherboard, or, you know, any other motherboard, because what if this did send some high voltage into the DC rails, causing some kind of damage? That was just too risky for me. But on the other hand, running the DC load like I was on here, it should have been fine, but this thing was not starting. But we could easily have bad potentiometers, I didn't even check those, and all sorts of other issues that would keep this thing from running. If you'd like to see me really try to spend some more time with this and try to revive this, I don't think it got destroyed by letting a little bit of smoke out. If you want to see me try to revive this thing and get it running at least, I can do that. At the minimum, I need to get a new fuse holder attached, and that way we can operate this thing safely without the light bulb. Yeah, like I said, I don't want to do it without a fuse. Then I can attempt to use the DC electronic load to load up the 5 and the 12 volt rails to get this thing booted up, or powered up that is, and then perhaps get the CRT section working as well. There's so much rust around the core of the flyback. It just has me wondering. But who knows, stranger things have happened, right? I have to say, it continues to amaze me how resilient electronics from the 80s are. I really don't think if you had a modern laptop and you stored it in water and it got all rusted out, that it would work. And obviously the tiny size of the components has a lot to do with it because, you know, a blob of corrosion on a through-hole chip with a big leg, that's got a lot more metal to eat through before it causes damage, or even the traces versus the micro traces and whatnot that are on modern stuff. But it's still just amazing that this is a computer. It was stored in water for like years or whatever, and there it is booted up into its original operating system and just ticking along with its original CRT, which, yeah, looks really good now that it's kind of had time to warm up and wake up again. So there you have it. That's it for the field found Macintosh Plus. Another field found machine on Adrian's digital basement. And yeah, look at that corrosion in there. Thanks very much, David, for giving this to me up at VCF in Seattle, and it's pretty cool to see it working again. And if you liked this video, I'd appreciate a thumbs up, but if you didn't, you know exactly what to do. Huge thanks to my supporters to make it possible to do this full time, and you can become a supporter at the links in the description. Comment down below, and you know, all the other usual YouTube junk, and that is gonna be that. So stay healthy, stay safe, and I will see you next time. Bye-bye. We'll just turn this thing off. Pew!